Okay, so again, determinant of a 2 by 2 matrix given by this formula, it's obvious. Okay? Reason for this, at least some of the reasoning behind it, is that if I multiply, well, if I have the matrix equation that we see here, well, that matrix equation translates to this equation, right? And you get a solution as long as Cx plus dy, and I say you get a unique solution, as long as Cx plus dy isn't a multiple of Ax plus By. Because if this is a multiple of this, then when you eliminate x, you're going to also eliminate y. Okay? And, well, this isn't a multiple. I watched those dang boards and didn't take a picture of them. It's all right, you know, the videos of the boards are still going to be up there. No big deal. Okay, Cx plus dy is a multiple of this if and only if AC AD minus BC is not equal to 0. Okay? If this is a multiple of this, then AD minus BC is 0. Okay? So this is a test for when you can solve this equation. Okay? Also, this matrix is invertible. Okay? Because it's invertible if and only if you can reduce it to the identity. Well, that ain't going to happen if CD is a multiple of AB. Okay, if this row is a multiple of this one, then again, eliminating one of these things is going to eliminate the other one. Okay? So you have these properties of determinants already as long as you have a 2 by 2 matrix. Okay? Also, if this matrix defines a transformation T from R2 to R2, in other words, from the plane to the plane, the image of any region has absolute value of AD minus BC times the area of that region. And an image of a loop in R2. I'm going to call it a simple loop, and I'm going to leave that undefined. I just mean something that goes around some path in the plane and ends up where it started from. That's a loop. And doesn't cross itself. If it crosses itself, then you get confused about orientation. And you can generalize it, but we don't want to go into that much topology. Okay, the image of a simple loop in R2. And I'll say a simple oriented loop. By oriented, I mean you have some direction that you go around this loop. Okay? And I'll say the same orientation, same direction. That is direction, okay? If and only if AD minus BC is positive. Okay? Meaning that if AD minus BC is negative, well, there's either one direction, one orientation, or the other in R2. If it's negative, it's going to be reversed. Now, we've already seen that, by the way, the examples you did, the work you did with the unit circle, right? So just telling you something that's in a lot of ways no surprise, but all these things are connected to this determinant. The invertibility of the matrix, the orientation of regions, okay? The size of regions under transformation. How does the region get bigger or smaller? Does the area or volume if you go into 3 dimensions, or hypervolume if you go up into n dimensions, does it get bigger or smaller? Okay? Those are fairly intuitive ideas, right? Now, go into hyperspace, well, you got to go back to your 2 and 3 dimensional intuition, which is what we're trying to develop. Okay? Make sense?